Now, in the second chapter, that is atomic structure, we have to study about the different models of the atoms. Children like Rutherford model, Bohr model, plum pudding model given by Thomson, and some more about the spectrum and the properties of matter. But before going to start the real atomic models or the points, we have to go through some basic points. As you know, atoms, you have an idea about atoms are electrically neutral. Atoms are made up of electrons, protons, and neutrons. So the point is how the electrons, protons, and neutrons were discovered. Actually, we have to see about the electrical nature of matter. Matter has electrical nature. You might be knowing when we rub any comb on any cloth or lay it on our hair, dry hair, what happens? The hairs are attracted toward the comb due to this static electricity. It means there is something lies in the matter, and so the different particles, and so you have an idea about the Michael Faraday static electricity. So this is the reason that matter has charged particle. Suppose we rub any comb or any plastic object on our hair or any woolen cloth, what happens? The particles are attracted, or the small pieces of paper are attracted. Why? It means some charge is generated on their surface. So this is the point. So moving forward, children, we will see about the discovery of electrons and discovery of electrons by cathode experiment. So first we'll see about the discovery of electrons, how the electrons were discovered, and we'll see about the discharge tube experiment. Discharge tube experiment. So children, discharge tube means a tube in which the pressure of gas is very, very low. You know this thing, that for the conduction of electricity, there is the requirement of a medium. Medium is required, like conductors. Conductors are required. But just I am here throughout the electricity. And so I am not getting hurt because in this place the normal atmospheric pressure is 1 atmosphere. So current cannot flow in 1 atmospheric pressure. But when the pressure is decreased very much, as in case of discharge tube experiment, so the gases act as conductor. And so this is the discharge tube experiment. Now, a discharge tube experiment involves a discharge tube cylinder. So discharge tube is nothing, but it is a hard glass tube. It is a hard glass tube. Approximately it has 1 meter length approximately, and there is this type of arrangement, and here we have this side tube. So this is around 1 meter long and 1 centimeter diameter. This is hard glass tube. This is hard glass tube, and this is high tension around 20,000 volt. High tension transformer, high tension source. Now this is cathode negative. This is cathode. This is the metallic disc. This is, as cathode is here, so here there is the anode. Now this side tube, it is there to suck to the air, or it is connected to vacuum pump to take out the air. And here the air pressure is very low. Air pressure is very low. Now to start with the experiment, this side tube is connected to vacuum pump or to suction pump to reduce the pressure, because at normal conditions current cannot pass through any gas. And here the pressure is very low. It is around this 10 to the power minus 2 atmosphere. 10 to the power minus 2 atmosphere. Very, very low pressure. 10 to the power minus 2 atmosphere. Here the pressure is 1 atmosphere. So it is minus 2, means 0.001 atmosphere. And so children, when the current is passed through this is what discharge tube. So the origin of very faint light takes place. So very faint light is originated. Very faint light means very light beam is emitted. And so the light beam has certain properties. So the properties what that light beam is emitted, and when some metallic object, opaque object, say thick metal sheet was placed here to stop the rays. So rays are coming throughout, and rays are coming from the negative going to positive. So if we metallic plate, this is the metal or metallic plate. So if metallic plate is placed or the rays are stored by metallic plate, the plate becomes hot. So this is the observations. So when the cathode rays, the rays are actually coming from the cathode, so it is called as cathode rays. And so we'll see cathode rays. Actually initially they are called as cathode rays, later on they are called as electrons. So when the cathode rays were stopped by a thick metal plate, it becomes hot. Metal plate becomes hot. This indicates that the rays have heating effect. Now second is, if we remove here the metallic plate, and if something very light wheel and pulley, like this here, wheel and pulley, this is wheel and pulley is placed. So what happens, as the particles are there coming out, and so this begins to rotate. So the rotation of light wheel inside indicates that particles have material nature. Particles have material nature. They are made up of particles. They are made up of particles. Now we have seen the two observations. Now coming to our children, third observation. About the application of electric field. So if we apply here any electric field, let it be positive here and here there will be negative. So third point is that when electric field is placed or applied around the cathode ray tube, so there is the deflection of rays. So here initially they will start, and so they will start moving like this. The deflection of, here there is this positive plate, metallic plate is there. So there is the deflection of cathode rays towards the positive plate, indicates that are negatively charged. They are negatively charged. The rays which are coming from the cathode, they are negatively charged. They are bending towards the positive plate. If here I have drawn here on the lower side, if put here, so they'll move upward. They are very, very small in size. Actually, children, this experiment was, performed by William Crookes. William Crookes was the person who performed the experiment. So this is the third. Now coming to magnetic effect. If we, in place of this plate, if we put a magnet, let it be the magnet, let the North Pole, so they will bend towards the magnet. So cathode rays bend towards the magnet, indicates that they have magnetic nature. They are magnetic in nature. Their attraction toward the magnetic field indicates that are magnetic in nature. Children, next point, when they are allowed to fall on certain heavy metals like molybdenum, tungsten and copper, there is the production of X-rays. So here, if you put here some obstacle, let it be the obstacle here, and here there is a obstacle, and it has some let this circle with the hard metal like molybdenum or copper or tungsten, and so the rays are concentrated by any means. So rays are allowed to fall on the metal piece present on the obstacle. So there is the generation of X-rays. X-rays are generated. So these are X-rays. X-rays, you know about the X-rays. Unknown rays. X-rays were called as Roentgen rays. William Conrad Roentgen was the first who explain about the X-rays. So, fifth point is when cathode rays are allowed to fall on heavy metals, there is production of highly energetic rays called X-rays. X-rays are produced. There is the production of X-rays. So this is there. Now 6 point children, they cause ionization. What is the reason behind this? Why current is flowing in the discharge tube or the tube having very, very low pressure? It means there must be origin of some charged particles. So cathode rays cause ionization of the gas taken inside. There is the ionization of gas taken inside. How? See here, if take here hydrogen atom, so under the high potential, very high, it can be 10,000 to 20,000 volts. So here there is the under high tension, we write here high tension or high potential or high potential. There is formation of this type of particle. And now this, what is this? This is the proton. And so this electron is emitted. And so this is there. So it means what we can say about the summary, that cathode rays are nothing but the negatively charged particles. What? Cathode rays are nothing but the negatively charged particles. So this is about the discharge tube experiment, and it is the J.J. Thomson who named them as electron. So after the discovery of cathode rays, it was the J.J. Thomson who performed an experiment and find out the charge and the mass of particles, and he named them electrons, as the particles, they are responsible for the conduction of current in the discharge tube experiment having very, very low pressure. So he determined the charge and the mass of the particles by several experiments. See how. So Thomson performed experiment using the discharge tube experiment made by him, and children, he actually found charge to mass ratio of the particles, or E upon m ratio, and he found 1.76 into 10 to the power 8 coulomb per gram. 1.76 10 to the power 8 coulomb per gram. So after, there was other scientist, other person, Millikan performed oil drop experiment. He performed oil drop experiment, and he found the charge on an electron by his experiment, and charge was found to be charge. He actually calculated the charge by his experiment, Millikan oil drop experiment. And actually in Millikan oil drop experiment, there is a chamber in which there is the positive and negative charge is applied, and very fine oil droplets are passed, and through powerful microscope the movement of the particles, again there is the discharge and there is the vacuum, and so the particles are monitored to flow in uniform, and it is very complex experimental setup, and so the potential is applied, and so the location, the movement of the particles is noticed, and then through different calculations the charge is determined. And so on the basis of his experiment he found to be 1.602 10 to the power minus 19 coulomb. This is the charge on an electron. So as you know, this is the here. So the mass of electron, you know, it was determined by the charge. This is the charge E, and this E upon M ratio, and so the mass was determined. And so on the basis of calculation we put the value of this charge and this E upon M ratio here. So it was found to be 9.1 into 10 to the power minus 28 gram, or found to be 9.1 into 10 to the power minus 31 kg. So this is all about the discharge tube experiment.